Sometimes in math, you want to be able to say that one number or quantity is larger or smaller than another. We have a couple symbols for that, and we're going to kind of develop that in this video. So first of all, the vocab word, so you know it when you see it, inequality. There's a couple of symbols that are inequalities. Specifically, we'll have these guys, which I know you've seen before at some point in your math careers. You can also have the ones with the lines underneath for or less than or equal to, greater than or equal to, which we'll talk about more in depth later on in the year, for later on in this chapter even. These first two, though, are going to be the primary focus of today's video. So, when you're looking at these symbols right here, I like to actually be able to give words to them so you can put things into words. When you see this guy right here, that first symbol, that symbol is pronounced less than. I find that it's very helpful for kids to be able to do this because a lot of them don't know this already, and it makes it a lot easier when you're trying to figure out which side is bigger or smaller than. Less than, you can see right here, the symbol almost looks like a sideways slanted L. L for less. So when it's facing the other way, you would pronounce that symbol greater than. This one with the line underneath means less than or equal to and greater than or equal to. Again, we'll get to those later in this chapter. For now, we're just focusing on those two. So what we want to do is maybe if I have two numbers, like maybe say I have 10 and 4, I want a way to compare those two numbers and say which one's bigger. So if you're looking at this right now, it's pretty clear that 10 is the bigger of the two numbers. So I want to say that 10 is greater than 4. Greater than is a symbol right here. And if you look at this right here, another silly way to remember this, picture this like a little alligator or Pac-Man or a fish or whatever you learned. It's really hungry right here, and he wants to eat the bigger of the two numbers. So the open side is like his mouth. He wants to eat the number that's bigger of the two. So 10 is bigger, it wants to eat 10. If I were to look at another situation, maybe I had -6 and -4, I want to know which one of these numbers is bigger. Well, -6 is the smaller of the two numbers. When you have negatives, the farther you are to the left on a number line, the smaller you are. Bigger numbers go to the right. If we were to sketch a quick number line right here, there's 0. -4 would be right here. -6 would be like a little bit past there. -6 is smaller, so it's less than -4. So the alligator wants to eat the bigger number here of -4. I'm going to switch whiteboards here, and I want you to pause the video and try out these 6 problems for yourself, kind of combining the stuff that you've been seeing with the absolute values, the square roots, and all that good stuff. So try these 6 out, pause the video, and then come back and see how you did. So looking at these right here, now that you've tried them out for yourself, I'm going to go ahead and run through these. If I look at this first one right here, there's a negative outside my absolute value. I'm going to do my absolute value just like normal, like the parentheses. I get 5. But there's a negative sign waiting outside. So that doesn't go away. It stays as -5. The negative was outside the absolute value, so it did not turn into a positive. Your answer for that part is -5. So if you look at these two numbers right here, -5 is the bigger number. It's going to be a greater than symbol like that. When you see a problem like number 2, I would definitely advise you to turn these two numbers into decimals. 5/4 is 1.25. 6/5 is going to be 1.2, or since the decimal stops, that's really 1.20. There's no more numbers after that. That makes it easier to see the bigger number. That's like $1.25 versus $1.20. That number is going to be greater. For the next one right here, you do the same sort of thing. I would definitely turn this guy into decimal. This says 3.605 about. Well, this one is just 3.60. Having that extra 0.05 makes it a little bit bigger. So this says 3.6 is less than the square root of 13. On my next one right here, 2 minus 5 is -3, but it's the absolute value of -3. Absolute value of -3 is a +3. Be careful of little problems like this because you'll see that -3, like, oh, they're the same thing. But 3 is bigger than -3. This should be a greater than. On my next one right here, if I type 8/3 into my calculator, I'm going to actually show you guys this right here. I ended up with 2.66666 repeating, and then there's a little 7 at the end there. That 7 is my calculator's way of rounding. It ran out of room. The 6s are going to keep on going forever. It rounded that last 6 to a 7. So don't trust that 7 when you see it right there. This is 2.6 repeating. So this one is going to be 2.6 going on and on and on and on and on like that. And this bar on this first part right here means the same thing. When you see that, that means the number under the bar repeats. So this also is 2.66666, same thing. They're equal. If I would have seen on my problem, just as a side note here, like if this had said 2.61 with a bar over both, that would mean 2.616161. The part underneath the bar is what repeats. But that's just kind of a side note right there. And on my last problem right here, I have negative 2.555555 going on, and just negative 2.5, or in other words, negative 2.50. Well, if I look at these, would you rather owe somebody $2.50 or $2.55.555? This number is a little smaller. On a number line, it'd be a little bit further to the left, so it wants to eat the bigger number, which is negative 2.5.